Welcome to the TPC desktop video series on using geodetics. In this video, we're going to look at entering grid bearings and distances, or what we call grid data, and then we're going to take a look in a contrasting way how we enter geodetic bearings and distances, or geodetic data. We've opened up the survey called Learn Geodetics. It's one of the sample files, and we use it in the Geodetic Learning Guide. Let's go ahead and take a look at a traverse we've created here in the traverse view called East-West Grid Bearing. And we're going to take a look at the northing and easting that we've entered here. And I'm going to swap over to a different drawing, which is that same grid east-west line. Let's open that up. And we can see that here we've created 6 points, each one about a mile apart. And we've basically gone due west on a grid, so we expect our coordinates to be the same. Let's open that traverse view back up in the northing. So all our northings are the same. But if we take a look at the latitudes change as we move farther west. And we expect that because the grid coordinates and the latitude don't line up except at the principal meridian. Okay, so this is exactly what we expected to see here. I want to bring you in real quickly to the survey information and take a look at the fact that for this particular survey, we have a project elevation of 1,500 feet, and by and large, we want to work geodetically. So we want to use geodetic distance and true bearings. But we're going to override that in this traverse setting. I'm going to bring those up with the button here for Format View, and we're going to look at the Advanced tab. And here you can see that we've overridden three things. We said we're going to enter data in units of chains, not feet, which are the survey unit. We're going to enter distances as grid distance, and we're going to enter direction as grid bearing. So we just pick these from the list. Here's the bearings, here's the distances. And now these control how this traverse is computed. So I start then by entering either coordinates for the first point or a geodetic position. It doesn't really matter. Either one's okay. And then I enter grid bearing and distance. So here I've switched to display raw data. I used Shift F9. It's a toggle that goes back and forth. And I've said, show me the data that I've entered. Well, I can see that I started with coordinates for point 1, and I've entered the rest of the points by grid bearing and grid distance. So Traverse PC is going to compute coordinates based on that grid bearing and distance, and then from those coordinates it's going to derive the latitude and longitude. So if I press Shift F9 to toggle back to the inverse mode again, I can see that now I have my latitude and longitude and the convergence for each one of those points. So just as I expect, since I entered all of these courses due west, my bearings show due west, and if I click back on the drawing, and I need to just switch this over real quick, so that it too is displaying grid bearings and distances. And we'll set this to show chains just like the traverse was. So now they're going to match up exactly. I now am displaying grid bearings and grid distances in chains for this traverse, and it exactly matches what I had in the traverse view. And I'll slide that up so we can see that these are the same. So if I'm not concerned about geodetics at all, and I just want to work with grid coordinates, and this is how I would enter that data. So let's make the quantum leap now into geodetics with Traverse PC. I'm going to close out that traverse. I'm going to come back to a drawing called True East-West Line, and I'm going to go into the traverses, and let's turn off this section area just for a moment here, and let's open a traverse called East-West True Bearing and see what this looks like. Now notice that we have turned off the columns for coordinates, so I don't even want to see the coordinates right now. I'm just going to work geodetically. In this particular traverse, I've entered latitude and longitude, and then I've entered the same data, the same values. My true bearings are 90 degrees west. My geodetic distance is 80 chains. But a geodetic distance is not the same as a grid distance, and a true bearing is not the same as a grid bearing. So I'm going to expect some differences, and we're going to talk about those here. So let's come in and look at the same things we looked at in the grid traverse earlier. Let's come up to our traverse format. Again, our units are in chains, but look at our distance and direction type now. From the distance list, we've chosen geodetic distance at project elevation, and for the direction, we've chosen true bearing at mean course convergence. So when I enter data, I'm going to be computing geodetic positions. Now if I do a Shift F9 again, I can see that I'm starting with a latitude and longitude, so I'm starting with the geodetic position. I'm then entering geodetic bearings and distances. So Traverse PC is going to compute from those geodetic positions for each of those foresights. From those geodetic positions, then it can, if I want it to, derive the northern and eastern coordinates. So let's shift F9 to move back to all the inverses. Anytime I want, I can choose Tools, Recompute. And I just went through and redid all the geodetic computations here. So now let's drop out to our drawing. And here we see the geodetic line that runs on a true bearing east and west. Notice that it's not quite horizontal. It's not quite the same as a grid line. In fact, if we were in this drawing and we said, let's look at that grid bearing traverse, our grid line does run horizontal east and west, but our true geodetic line doesn't. Okay, this is exactly what we would expect based on where we're at on this projection. In other words, we're east of the principal meridian, so I expect my true west line to drift south. In other words, the bearings, grid bearings would change, but the geodetic bearings stay the same, 90 degrees west. I want to drop back into the traverse view just for a moment, and I want to show you that if I highlight a true bearing and then look at the status bar at the bottom, it tells me the true bearing is based on the mean course convergence. If I had chosen a different option and I said I want my direction to be based on a true bearing like 2 degrees 30 minutes, okay, and let's put in 130, okay, so now that's the value that it's based on. I could come back to Traverse PC and display a bearing, and do you see what it says now? This true bearing is based on a mapping angle of 1 degree 30 minutes. Same way with the distances. Let's click on a distance here, and I see that this is 80 chains based on the project elevation of 1,500 feet. Let's change that. Let's go in and say I want this to be a geodetic distance at the ellipsoid surface. So now when I highlight a geodetic distance, it tells me it's at the ellipsoid surface. Notice that the geodetic distance changed from 80 chains to 79.99. That's because it's currently still inversing between those geodetic positions, and at the ellipsoid surface, that distance of that geodesic is just slightly shorter than it is at a project elevation of 1,500 feet. Had I entered the data with the ellipsoid surface already selected, I would have gotten this, Tools, Recompute. And Traverse PC now has recomputed those positions based on 80 chains at the ellipsoid surface. If I now were to switch back to a project elevation, like we had earlier, I'm basically going to see the reverse happen. Now these inverses at project elevation are slightly longer than the inverses at the ellipsoid surface. And again, I would correct that just by saying Tools, Recompute. So we can see that one of the cool things the Traverse view does is that it does two things at once for me. If I'm entering data, it uses that distance and that bearing to compute the foresight based on whatever distance and direction type I've selected. If I'm recalling existing survey points, whether they're geodetic positions or grid coordinates, it inverses between those based on the distance and direction type. So I can kind of have the best of both worlds here in one place. Let's look at one final thing here. I'm going to go back up to the distance and direction type, and let's go back to our true bearing based on mean course convergence, and let's switch to a geodetic distance based on mean course elevation. I want to talk about the fact that Traverse PC can do more rigorous computations if you ask it to. And notice that I've got point 2002 here, or 202, at a 5,000 foot elevation. Okay, let's go ahead and do a Tools, Recompute. So I'm using 80 chains of geodetic distance between 201 and 202, but my elevation goes from 1,500 to 5,000 feet. I'm using 80 chains to the next point, but it drops back down to 1,500 feet. And just for the heck of it here, we're going to increase the decimals that Traverse PC displays. Let's go to 4 decimal places. Let's open that Traverse back up again. Okay, so we're displaying greater distance here in the chains. And now let's switch back to one of these other distance types. Let's choose the ellipsoid surface here. And we expect to see some slight differences because I was using a mean elevation of the course when I computed that foresight, So if my elevations for another course are different, I expect to have a different distance. And in fact we do. Notice that 201 to 202 and 202 to 203 both are 79.9876 chains. Now when I drop back down to a constant elevation of 1500, I have a different distance, 79.9943. So again, the distance type and direction type allow me really to get at exactly what I wanted to compute or exactly what I want to show for inverses between the coordinates or the geodetic positions that I have.